Hello, everyone. Good morning, good afternoon, and thank you for joining. We'll give maybe 1 more minute for people to join or dial in, figure out go to meeting or go to webinar, and then we'll kick off the presentation. Thank you. Okay, I think let's get started. We'll let people come in and catch. We can catch them up later, and we can open it up for some Q&As later in the presentation. My name is Bhavin Shah. I'm a technical marketing manager with Portworx, which is the cloud native business unit at Pure Storage. And I know when you signed up for this webinar, you might be expecting Andy to be my co-presenter as well, but Andy has dad duties and is on paternity leave right now. So I'll be the one who's covering the slides and the demos, which is different from the way we have done this in the previous months. But with that, let's get started. The topic for today is improving compliance and resiliency of your Kubernetes workloads with PXBackup 2.1. So PXBackup 2.1 is the latest iteration or latest release of our data protection product from Portworx. We announced it in August, and now it's generally available on the AWS marketplace for anyone to consume. So we'll talk about in this presentation from an agenda overview perspective. We'll talk about why data protection is different for Kubernetes compared to virtual machines. We'll talk about what PXBackup is, how it fits into the Portworx portfolio, and then specifically talk about what new features were introduced in 2.1. And then we'll just do demos. We have one live demo. So we do have a PXBackup 2.1 instance running. And then we have a couple of recordings because I wanted to do more things. So we can't do everything live. We'll do something live, and then we'll look at some recorded demos with some cool architecture diagrams. So with that, let's get started. Let's kick it off. So let's start by talking about why backup is essential for enterprise application. Data protection is key. Like if you are pushing apps to production, if you're running mission critical workloads, data protection is, or backup and restore is not just good to have, but it's a must have. Like you need that level of protection, level of resiliency, even for compliance reasons, you need a data protection solution. If you are from the Europe region, right, EMEA, where GDPR is enforced, regular backups are essential. That's actually one of the articles that's listed in the whole GDPR Act if you have read through it. Most, if not all, enterprises have recovery demands. So like when your backup administrators, or now in the modern world, your DevOps admin meets with those application owners or application developers, there are SLA requirements around how fast can we recover from a failure. So for example, if US East 1 goes down in AWS, how fast can you recover? Can you bring your applications back online on a different region in AWS, or can you bring it online in a different cloud completely? So we'll in this demo, in this monthly demo, we'll obviously talk about those scenarios and see what's supported, how you can restore from failures. In addition to PXBackup, which is the main topic for discussion today, we also have other products in our portfolio called PXDR, which definitely help with building synchronous DR or asynchronous DR replication. PXBackup is a data protection solution which will help you back up your Kubernetes application and restore them to a new region. And then from a security perspective as well, the number of stories that we hear around ransomware attacks or around security breaches, it's definitely good to have a snapshot location that's stored in a remote site, an offsite location. If you're running on-prem, if you're running your Kubernetes clusters on-prem, you might want to store an offsite copy in an S3 repo in one of the AWS regions. So from a security perspective as well, backup is really essential. What does that mean? Like, okay, let's talk about backup for Kubernetes. And if you look at the GigaOM data protection radar, you'll see that Portworx is definitely at the very top of it. We are recognized as a leader in Kubernetes data protection, according to GigaOM research. So we know what we are talking about. We have been helping out customers and like figure out data protection for Kubernetes, for containers, and then build those hybrid and multi-cloud architectures using Kubernetes. As we spoke about earlier, PXBackup falls in a portfolio of different products from Portworx. So Portworx does have PXStore, PX Autopilot, PXDR, PX Migrate, all of those things. But then our topic for discussion today is PXBackup, which is a native Kubernetes native data protection solution that was built for Kubernetes. We didn't have like a legacy product that we tried to morph into something new that supports Kubernetes. It is built for Kubernetes. It runs on Kubernetes, so you can actually deploy it on the same cluster that you have your other applications running, or you can run it on a different cluster, dedicated backup cluster, and you can have multiple instances of PXBackup running in your environment, cloud or on-prem. So PXBackup is built for your Kubernetes clusters. Talking about 2.1 specifically, with 2.1, so okay, let's take a step back. Let's talk about what things look like before 2.1. Before 2.1, PXBackup, obviously, again, all the same set of features. We did support all containers, all applications. We support all cloud offerings, but we had native integrations built into AWS, Azure, Google, and then definitely we had Portworx as our storage layer for any Kubernetes cluster, and these were supported completely. With the 2.1 release, we now support additional things like, okay, if you are using a CSI plugin, so if you're not using Portworx as your Kubernetes storage layer, let's say if you're using Red Hat OpenShift and OpenShift Data Foundation or ODF product, or if you're using just Amazon EBS, or if you're using even say NetApp storage with the Trident CSI plugin, Portworx PXBackup can now help you protect all of those different backends, storage backends, without the need to install Portworx Enterprise on top of your Kubernetes cluster. Second, from a compliance perspective, we now support 3-2-1 backup rule. So this is an industry standard. So if you have been around in the data protection ecosystem, not just for Kubernetes, but even for virtual machines, you're aware of this. 3-2-1 basically means 3 copies of data on 2 different types of media, and one of those copies has to be in an offsite location. So we'll see how PXBackup helps you comply with this new, or with this existing backup rule that many organizations and enterprises have. And then the third one, which is a really cool feature that we introduced, was around protecting file shares. So we have customers who, if they're not using Portworx for their ReadWriteMany workloads, they might be using in the cloud, they might be using Amazon EFS, Elastic File System, as the layer of persistent storage for their EKS cluster. So without having to ask them to move to Portworx, we can now help them protect those EFS backed persistent volumes, along with everything else that's included as part of that containerized or Kubernetes application. If customers are using file systems on-prem, like one example can be pure FlashBlade. If you're a pure customer using FlashBlade as your backend to provide ReadWriteMany volumes to your Kubernetes pods, we can help you protect those as well by directly talking to the file system, doing a live backup, and then storing a copy offsite. So those are the 3 key or shiny features that we have in PXBackup 2.1, in addition to other enhancements that obviously we introduced. If we talk about the architecture, again, you can have your application, your Kubernetes app running anywhere, on-prem, in the cloud. Choose your own Kubernetes or bring your own Kubernetes cluster, run your app. All you need to do is add that cluster to PXBackup, and obviously as part of the live demo, we'll go through that process and show you how easy it is, and we'll talk about different role-based access control policies that you can enforce using PXBackup. But then once you have added your cluster, PXBackup will go ahead and inventory all the different namespaces that are configured in your cluster. Usually when you're deploying containers or containerized applications, those are namespace bound. So we understand that, and we'll basically inventory all of those resources, identify all the Kubernetes objects. So it doesn't matter if your application was deployed using an operator, or it was deployed using a Helm chart, or if it was just deployed using YAML files. All of these models are supported. We'll identify all the different Kubernetes objects from pods to any custom resources to deployment objects, any storage configurations, so like persistent volume claims, all of those things. Networking objects like service endpoints, load balancer IPs, like load balancer configuration, ingress configuration, all of those. We identify all of that, take a snapshot, and then store it in an S3 compatible storage repository. So this can be your on-prem S3 backed storage repo. So this can be FlashBlade again, if you're using on-prem, or if you're storing copies in the cloud, you can use AWS S3 or Azure Blob Storage or Google Cloud Object Storage as well. Again, IBM Cloud is also supported, so you can use any of these. And then once you have this backup taken, you can use PXBackup to restore an application that's running anywhere to a Kubernetes cluster that's running on a different cloud completely. So you can migrate it from like one region of AWS to another region of AWS, or you can take an app running on AWS, move it to Azure, take an app that's running on-prem, move it to Google Cloud. All of those different combinations are supported. Again, the benefit with 2.1 is you don't need to be running Portworx. You can take your CSI-backed storage that's running on-prem, move it to AWS without the need of any specific migration services, just by using this data protection tool. Okay, next, let's talk about 3-2-1. We already spoke about what the 3-2-1 mean, but 3 copies of data, that means your production copy, which is your live application data. We store a local snapshot for every time that backup job is triggered, and then we offload based on a retention policy that you specify. We'll offload these to an S3 backed repository. 2 copies of data, again on-prem when you're running. So the first 2 copies, the primary and the local snapshot, will be stored on the same Kubernetes cluster, will be running on the same Kubernetes cluster. And then the third copy can live in an S3 compliant object cloud storage bucket. And one offsite, obviously, this can be remote. It can be a completely different on-prem data center environment. If you have multiple data centers and you want to store backups in the secondary data center, so you can restore quickly, you can do that. You can move it to the cloud, and all of this data that's being transferred back and forth is encrypted in transit and at rest. So you don't need to worry about any security breaches as well. The support for file system backup, we already spoke about some of this. If you are running any type of NFS or shared file system, AWS EFS, on-prem FlashBlade, all of that is supported using Portworx PXBackup 2.1. We'll take a backup and you can offload those to any S3 repository. So with that, that's enough for slides. I think we spent like 10 to 12 minutes. Let's just jump into demos, and then I have a couple of slides at the end to show you or to like talk about how you can get started with PXBackup. Okay, so let me move to my Google Chrome browser, and I hope this is readable for everyone. I did test this before we started the broadcast, but this is my PXBackup 2.1 installation, where we have a Red Hat OpenShift cluster that's installed using installer provisioned infrastructure running on AWS in the US East 2 region. And then we have an EKS cluster that's running in my AWS account as well. So we'll also show up how you can move your applications from OpenShift to Amazon EKS using PXBackup. So both of these clusters are already added, but if you want to add more clusters, by using the PXBackup dashboard, you can click on add cluster. Here you can give it a name. You can just copy this kubectl or kubectl config view, flatten and minify flags enabled against your cluster. It will just spit out some information that you can just paste here, or if you have a kubeconfig file that you want to use, you can upload your kubeconfig file here. If it's EKS, GKE, and IBM Cloud Kubernetes cluster, IKS, you can select those. If it's just any other, like anything else from these options, or even an upstream Kubernetes cluster, you can just select others. The next thing is it a Portworx cluster or it's a non-Portworx cluster? So we do install a small agent, like it's just a small daemon set. So it deploys one pod on each node of your Kubernetes cluster called Stork, which is responsible for initiating those local backup jobs and is responsible for communicating back to PXBackup about the failure and success of all the different backup jobs that you might have running locally on the cluster. So if it's a Portworx cluster, you don't need to do anything specific. Stork is already up and running. If it's a non-Portworx cluster, right? Like for example, the Red Hat OpenShift cluster that I have for this demo, is running OpenShift Data Foundation, or OCS for people who were using it before the 4.7 release, OpenShift Container Storage. You do need to install Stork. So that's it. Like, we'll give you one command that you can paste against your cluster. Stork will automatically, like, we'll pull down a YAML file and install Stork, the latest version of Stork, and you're good to go. So that's how easy it is to add a new Kubernetes cluster. Additional things that you can do with PXBackup is specify pre and post backup rules. And here, like, pre and post backup rules basically help you take application consistent snapshots. So it's not crash consistent. You can specify rules on like if your application is running MySQL or Cassandra, we have those examples here. So like if you're backing up Cassandra instance on Kubernetes, you need to do a node tool flush for your persistent volume, or your application that's writing to the persistent volume, before you take that snapshot, to ensure that the snapshot that's being taken is application consistent and not crash consistent, because that's not how we do things. And you can specify a post exec rule as well. So like once it's done, we have to make sure that like we do a node tool verify for Cassandra. If you don't know how these different application consistent snapshots work, we have documentation for all the different stateful apps that we can support, and the rule, like we have sample rules for everything. Like for MySQL, what operations do you need to do, like flush tables with read log for your pod before you take that snapshot. So all of that documentation is available from, like, you can find this on backup.docs.portworx.com, or you can find it from the PXBackup UI as well, just by clicking here. So that's how you can create these backup rules. Other things to highlight is, okay, you can add different cloud settings. So here you can see we have my AWS account and my Google Cloud account added. So by using this, I have configured 2 different backup locations. I have an S3 repo that I can store my snapshots in, and I have a Google Cloud object storage bucket that I can use to store my backup snapshot as well. So I can use PXBackup to configure or customize my backup job. So every hour it stores a snapshot copy in AWS, but then every day or every 8 hours it stores a snapshot copy in Google Cloud Object Store bucket as well. You can do that using PXBackup UI. And then the next thing is schedule policies. So you can define schedule policies. PXBackup allows you to take a backup snapshot on an on-demand basis or an ad hoc basis. So like when you create a backup job, it automatically initiates one snapshot, stores it in the repo. But to comply with your SLA requirements, you can have different schedule policies. And this is where role-based access control from PXBackup helps you, right? So in addition to just adding clusters and adding these cloud accounts, backup admins or DevOps admins can define these schedule policies. So you can have an hourly or 15-minute. Let's just do it. Like let's select a periodic and select every hour. And then this is where you specify how many snapshots you want to retain and how many of those will be incremental in nature. So your DevOps admin or your backup admin can create these snapshot policies in advance for all your users. So demo policy, and then this, like we did an hourly one, but you can also do a daily, weekly, and monthly policy. And when you create those backup snapshots, you can associate them with schedule policies. So like if I'm an application developer or if I'm an application owner who just wants to make sure that my application has backups, I can come and log into the same PXBackup user interface, but only see my cluster, only see my applications, no overhead. And I can come and use the cloud accounts or the cloud backends that my administrator has created for me. And I can choose from a set of schedule policies that my DevOps admin or backup admin has also created for me as well. So I can do all of this. So let's create a daily. So a policy. Every day at, let's say, 11 p.m., 11:59 p.m., I want to take a backup snapshot with a specific retention policy, and I can have that created as well. So that's how easy it is to configure all of these things. Now let's get to let's try creating a new backup job. So if I have a Red Hat OpenShift cluster, as we discussed earlier during the slides, a PXBackup will go ahead and inventory all the different namespaces that are configured, or in an OpenShift example, all the different projects that have been configured on your cluster. We have a simple WordPress application that we have created for this demo. It's running in its own namespace called WordPress-demo. I can select individual resources. So as an application owner or a developer, I can create multiple backup jobs. Let's talk about examples, right? When you have an application running, we don't see that the entire app needs to be protected every 15 minutes or every hour. Once you deploy, once you define the number of pods that you have running or the different service objects, they don't change so frequently. Like they may change over the span of a week or a month, but then every 15 minutes or every hour, they don't change. So you can have a daily policy that covers the entire namespace, and then you can come back and just select persistent volumes because you are writing more and more data, and those are the resources that you want to protect every 15 minutes or every hour. So based on what you decide, you can select different resources. Since we are doing this as a demo, I'll select all resources and then hit apply. And if I scroll back up, I can just hit backup, and this is where I can give it a name. So monthly backup demo, and then I can select a backup location. So this is something that the application owner or DevOps admin might have configured for me. I can select the one in AWS. Should have done a better job at naming that backup repo. The second one is pretty clear that it's in GCP. The first one I should have listed like AWS-PXBackup 2.1, but that's it. Like you can select a backup location. So this is the new feature that was introduced in 2.1. Since we are relying on CSI plugins to have snapshot capabilities, and we support those, you can select a snapshot storage class that has been configured for your storage layer that you're using for Kubernetes. So in this case, we're using the Ceph FS storage class for running my application. So the Ceph SF plugin for Snap class is the one that we'll select. Another interesting thing to point out here is before 2.1, we didn't have we could still support CSI snapshots and take store local snapshots, but now with this additional checkbox that you see here, we can offload these to that backup location. So now anytime a snapshot is triggered, it will basically take a snapshot and store it in the PXBackup 2.1 backup repository. Sorry about that. And here I can select an ad hoc or on-demand backup, or I can take it on a schedule. So this is where you will see the different schedule policies that we just configured. So hourly demo policies, the daily one. So as a developer, I know, okay, I need this app to be protected every hour. I can do that. If I was using WordPress, it's not, right now the demo application doesn't need application consistency. I'm okay with it being crash consistent. But if I was using a mission critical, if I was using a mission critical app for my demo, I would ideally configure these pre and post exec backup rules and then select those as part of my backup job as well. So now you have entered everything that you need to do to initiate a backup job. We'll hit create and let it run through. Like PXBackup now talks to the Stork instance that's running on my OpenShift cluster and initiate that backup job and then offload the backup to my S3 repository. It does take some time. We have a successful backup job from an hour ago that I did for this demo. So once a backup job is successful, you can click on show details, and here you can see that, okay, you have your origin cluster, you have the name of the backup, you have the backup location, snapshot class, the size of the backup that was used, whether everything was backed up successfully, so our status message, the namespace that was protected, the persistent volumes that were protected, all of those details can be found in the PXBackup UI itself. You can also look at this activity timeline that we have, or backup timeline that we have, and monitor your backup job. So every morning, if I'm a backup admin, right, I can come to this dashboard, look at my backup jobs for a specific cluster and see if any of those have failed. I can do that for 24 hours, or if I want to go a bit back, I can monitor it for the past 30 days as well. So PXBackup gives you a clean snapshot of how your backup jobs are doing. If we want to restore, so like the backup job that we initiated a few minutes back is also successfully completed, and it stored more data this time around than it did previously. If I want to restore from it, I can just hit on restore, and this is where I can specify a name for it, and then select a destination cluster. So I can select the same cluster in this case, or I can select the EKS cluster. I can do a default restore. So maybe I accidentally deleted the persistent volumes of the deployment objects and I want to restore my application to the same namespace. Or if I want to do a custom restore, this is where if I'm moving between clusters, it helps me select a new storage class to use for my restore operation. So let's say I want to move, right now I'm not moving clusters, I'm using the same cluster. I can use the same CEFS storage class that was used initially. I can do namespace mapping as well. So right now I don't have a demo namespace, so let's fix that. This is a CLI interface that's connected to my OpenShift cluster. If I do a get nodes, you can see we have 3 masters, 3 workers configured as part of this OpenShift instance. Let's do a kubectl get ns, and we list all the different namespaces. Let's just create a new namespace that will be used for the restore operation, right? So WordPress demo restore. So now if we do a get namespace, you'll see that, okay, we created a new namespace. Let's see if it picks it up immediately or if it needs some time or needs to refresh it. Sorry, it's behind one of my monitors, so I'll put it on the side. Let me go ahead and select it again and hit restore. So demo restore, same cluster. We'll do a custom restore. We'll select the same storage class from a namespace perspective. Let me just start typing. So WordPress demo restore. That's the namespace that we created for this restore operation. And then if I scroll down, I can, if I'm restoring it to the same namespace and I want a clean restore, I can select replace existing resources. We are copying it to a new namespace. We'll just perform a simple restore operation, and it does the same thing. Like it talks to Stork that's running on my OpenShift cluster, initiates the restore operation, starts by downloading the data from my S3 storage repository, and starts creating those persistent volumes. And once those persistent volumes are up, it starts deploying the pods and the service objects. So let's go back to the CLI and do a kubectl get all in the WordPress demo restore namespace. Right now you don't see anything. If I do a get PVC, you'll see that 30 seconds back we have both of those persistent volumes that are now created. So once the persistent volumes are up and running, that's when PXBackup moves on to the other Kubernetes objects that are part of this restore operation. So if we do a get pods, you'll see that we have containers that are in the container creating stage. I can do a get all again, and you will see that we have a deployment object, we have a replica set object, we have a service IP, and then we have pods that are going through their usual container creating stage as well. So going through crash loop, back off, and like it will eventually come up. But that's how a restore, that's how easy it is to perform restore operations. I can also monitor, like on the 4th tab, I can look at all the different scheduled backups that exist in my cluster for a specific cluster. So I can do that here as well. That's it for the first or the live demo piece of it. I'll move to the next 2 recorded demos that we have, where we talk about how we can backup and restore EFS file shares. And the second one is if customers want to move away from EFS because of its limitations to Portworx for their ReadWriteMany workloads, how we can leverage PXBackup to do it. So this is the first demo. It's a simple use case where I'm not using Portworx as the storage layer on my primary Amazon EKS cluster where I have my application running. The storage class basically backs into an EFS file system that's configured, and then any persistent volumes that are dynamically provisioned using that storage class are created in that EFS file system. So I hope that the audio from the video is not. Hey Katrina, do you listen? Do you hear the voiceover from the demo?
Not at the moment.
Okay, perfect. So yeah, I can. It's okay if it's in my earphone, but I can do it. So Here you can see we have an EFS back, and we are using an S3 repo for storing our backup snapshots. And we have PXBackup that's running on another EKS cluster. Everything is running in the same region. In this demo, we'll just do a backup and restore to the same EKS cluster. We won't restore it to a different cluster, although that's completely supported as well. So let's move forward and then actually look at the demo. So as a demo application, we saw WordPress. The second popular application running on EFS these days is Jenkins. So we have a simple Jenkins installation that includes a deployment service object, a pod, and a PVC for Jenkins Home. This is where it stores all the configuration data, all the plugins that you have configured for your Jenkins installation, all the artifacts that you have created for your Jenkins installation. And this is the PVC that gets created. It's backed by an EFS demo storage class, which is using the efs.csi.aws.com as the CSI provisioner. If we do a describe for that PVC, you can see that it's mounted by the pod that's running in the same namespace, and it's mounted to a specific directory, and it's using the EFS demo namespace. So let's do a kubectl get all again in the same namespace. And here we can see again, we can see all the objects. I just want to fetch the pod name, and here you can see we have Jenkins Home, which is something that you configure in the Jenkins pod, which is backed by a persistent volume claim called Jenkins Home PVC. So we know that anything that we configured in our Jenkins UI is backed by a persistent volume. So even if I lose the pod, I still have all my data persisted in that persistent volume claim. So we have customized our Jenkins deployment to configure a few things. We have a couple of artifacts, a couple of demo pipelines and freestyle projects. We have installed a bunch of plugins that are needed for running any Docker and Kubernetes jobs as part of my CI/CD pipelines. So we'll look at all the installed plugins. We'll specifically look at the Kubernetes plugins that have been installed, so then that when we delete this application and restore it using a PXBackup snapshot, we can verify that everything is restored to the way it's supposed to be. So now we know that, okay, Jenkins does have some data. It's not just a fresh installation that doesn't have any customization being stored or data being generated. Now let's go ahead and use the PXBackup user interface. This is a similar setup. So we have an AWS account and the same backup repo, in this case, like the PXBackup 21 S3 backup repo that's configured for my PXBackup instance. This is something that's configured by the DevOps admin or the backup admin. We have our EFS cluster, and then we have another EKS cluster that's used as the Jenkins restore cluster. We won't use the Jenkins restore cluster in this demo. We'll just use the EFS cluster. So once we click on the EFS cluster, we identify that the namespace, the Jenkins EFS demo namespace that's configured. Here we can go ahead and click backup. The same process that we went through earlier for the WordPress application, right? So we enter a name, we select a backup location. Since this is an EFS backed storage class, there's no need for a snapshot class. Instead of putting it on a schedule, let's just do an on-demand backup job. And this is where it initiates the backup operation against that EKS cluster and runs through like taking a snapshot of the entire application, storing it in an S3 repo. You can monitor all your different backup jobs from the same backup activity timeline. Here you can see that if a backup job fails, I had a backup job fail on me at 9 a.m. It shows up as an exclamation mark. So the backup admin knows that, okay, something went wrong. Let me try to fix it so it doesn't fail and I don't miss my SLAs that I've agreed on with my application owners. So I can select all of this. Now EFS backup is successfully completed. So as you can see, it copied 4 Kubernetes resources, so deployment, replica set, service, and pod, and 1 persistent volume. Everything was stored in that backup repository. You can click on more details, look at all the different deployments and persistent objects, persistent volume objects that were backed up as part of this particular backup job. Now let's go back to the CLI and we'll basically delete our Jenkins installation. So we have a simple YAML that we use to deploy this app. We'll use the same YAML to do a kubectl delete for that Jenkins EFS demo namespace. So we'll delete everything and then obviously run a couple of verification commands to show that, okay, we actually deleted things and didn't just like morph or mess with something just for the demo. So once the deployments and pods are easy to delete, the persistent volume takes a bit of time. So we'll wait for the delete operation to be completed. Once that's done, we can go ahead and verify that nothing exists in that namespace. So kubectl get all in Jenkins EFS demo namespace gives us nothing, no resources. We can also do a get PVC in the same namespace, and we'll see that the PVC has been deleted as well. So like if this happened in real world, this was time for panic. Like, okay, I lost my Jenkins CI/CD server, my builds are not happening. How do I fix it? You can come to PXBackup and use the latest snapshot or the last well-known or good snapshot that you had and perform a restore operation. So we'll use like the same storage class. We'll use a different namespace, Jenkins test in this case, and we'll restore all the different objects because that's what we need to do. We need to restore deployments and persistent volumes and service objects. Same workflow happens here. PXBackup initiates a backup restore operation. It pulls down the data, creates a persistent volume, and then goes ahead and creates a deployment pod and service objects that's needed for my Jenkins installation. Once the restore is completed, we'll do the same thing. Like we'll go to the CLI, look at all the resources being created, go to the new load balancer endpoint for our Jenkins UI and verify that all the artifacts and plugins that we had configured and the way we had customized our Jenkins installation still works, and like things can get back to normal quickly. So the restore job is now successful. Volumes and resources were restored successfully. I can come back. If I do a get all, you can see I have a new load balancer endpoint. So let me copy that, and then using it as the URL that I go to. Obviously, it takes a few minutes or a few seconds for the load balancer, ELB load balancer instance to come up in AWS. Once it's up, you can log into Jenkins using the same user credentials. So nothing new. If it's the same UI, same instance, it should work as is. So we see the same artifacts, the same screen message. If you go navigate to the plugin section, you will see that we have the same plugins that were installed earlier show up under this restored Jenkins object as well. So we can scroll down and you can see Kubernetes CLI, Kubernetes plugin, Docker plugin, all of those things exist. So again, this is how easy it is to like use PXBackup to backup and restore an EFS backed instance. Time for the second demo. And again, like if there are any questions, feel free to put them in chat, feel free to put them in the Q&A section. We'll get to it at the end, or if I see it pop up, I can answer them right away. This is a second scenario where I have a primary EKS cluster, which is backed by EFS, and we have a second EKS cluster that's running Portworx. So in this scenario, we have had actual customers that were using EFS for file-based persistent volume, so ReadWriteMany, and block-based persistent volume using Amazon EBS for their read-write once volumes, using two different AWS solutions for storage, persistent storage for your containerized applications. We have had those customers migrate from existing solutions to a Portworx deployment where the same Portworx storage layer can be used for both read-write once and read-write-many persistent volumes, and not just different multi-protocol support, but also additional features that we can talk about in a different monthly demo, and you can probably go and catch up on those demos on our YouTube channel. But we'll show a migration use case for this demo where we take a snapshot, store it in an S3 repo, and then restore it to a completely different cluster as well. In this case, we're using Jenkins again. It's the same primary cluster that was running EFS. So we have our Jenkins home directory, which is bound by a PVC, which is backed by an EFS backed file system. If we do a describe for the pod, you will see that the Jenkins home directory inside my Jenkins pod is backed by the persistent volume itself. So we know that any customizations that we made are persisted across reboots, pod failures, and you get that same level of resiliency. So now we have verified things on the CLI level. We'll now go ahead and like do the backup and restore job as well. So let me just fast forward or skip through the section where we verify the same set of plugins and configurations that have been made on the Jenkins UI or Jenkins deployment. Here we have EFS cluster and a Jenkins restore cluster. This is what we'll use. EFS cluster is our primary cluster. Jenkins restore cluster is our secondary or our target cluster. And we'll use the same AWS account and an S3 backup repository to store or host our snapshots for our Jenkins deployment. Another interesting thing to note here is our EFS cluster is actually running Kubernetes version 1.18, whereas the restore cluster, Jenkins restore cluster, is running Kubernetes version 1.20.7. So again, that's completely supported with PXBackup as well. As long as there are no breaking API changes, you can take an application that's running on one version of Kubernetes, migrate it to a completely different Kubernetes version as well. So performing the backup job, again, we can select individual resources if we want to, similar to how we saw it for the WordPress demo, from a deployment to a persistent volume to a service object. I usually, like in my demos, I usually select all. So we'll select all, we'll hit backup, and this is where you can configure additional details for your backup job. So we can give the backup a name, select the location, put it on a schedule, do the same thing all over again. So again, if you're following along, this is the third backup job that we are creating. This is how easy it is, that you don't need much time. Just select a few options and you have a backup job that's initiated for you. You can monitor the backup job from the PXBackup user interface itself. And then once it's successfully done, we'll go ahead and perform a restore operation to the secondary cluster. So here we have, again, it's the same number of resources. We have one persistent volume that's backed up and 4 different Kubernetes resources that are included as part of the backup operation. Backup is successfully done. So now let's move on to the restore piece. So we'll navigate to the UI, select the backup job that we want to restore from. Before that, let's look at the details. We look at deployments, persistent volume claims, everything that was protected as part of this backup operation. And then, excuse me, I have my secondary cluster, just have a different background for it, so it's easy to differentiate. Jenkins restore is a namespace that I've created for the restore operation. As you can see, we don't have any resources, so I didn't have a Jenkins app already ready to go in the oven. We'll perform a fresh restore operation, and as part of the restore, we'll also change the storage class. So here, since we are moving to Portworx, we have already configured a Portworx storage class called px-shared-sc, and in addition to it being a ReadWriteMany storage class, it also stores 2 replicas. So any data that's written on the ReadWriteMany persistent volume is replicated twice, or has 2 replicas stored on the EKS cluster. So it gives you an additional level of fault tolerance as well. So let's perform a restore operation. We'll give the restore job a name. We'll select the destination or the secondary cluster. We'll do a custom restore because we want to change the storage class that's used for the restore operation. And we'll select the px-shared-sc storage class. For namespace as well, since the same namespace doesn't exist on the secondary cluster, we'll select Jenkins restore as our namespace. That's what we have configured for the restore operation. And again, since we are migrating the app, we'll copy all the resources and move it to the secondary cluster. So let's perform a restore operation. Now, instead of restoring it to the same cluster, we are moving it to a different cluster. If I remember correctly, I was using the same Amazon region, but you can very well choose a different region altogether and perform that restore operation. If you do a kubectl get pods and just put a watch command on it, you will see the pods starting to come up after the persistent volumes are done. So our Jenkins pod goes from pending to container creating to a running state pretty quickly. But this is not it, right? We want to make sure that the app that was restored has the same set of customizations that were configured. So we can do a get all, capture the load balancer endpoint, and confirm that our persistent volume is using the correct storage class and the correct access mode that's needed for Jenkins. So px-shared-sc is our storage class. Let's copy the load balancer endpoint, the ELB endpoint that's configured for Jenkins, and try to navigate to it using our browser. So again, let's just confirm that the restore has been successful. We confirmed it using the CLI, so we'll just verify it using the UI as well. Again, if you are a backup admin who has been responsible for backing up virtual machines, you don't need to understand or learn how to use Kubernetes CLI. You can just use a new UI-based tool to protect your modern applications that your developers are building. Let's navigate to the new ELB endpoint and verify that our Jenkins installation is back to where it's supposed to be. So again, it takes a few seconds to a couple of minutes for Jenkins to like completely load, read the data from and mount the Jenkins EFS, Jenkins home directory. We can log in through the same credentials that we used earlier. You can see we have a name, we have our artifacts that we had created. We'll also confirm the same plugins that were installed earlier are installed as well. Since all of these things are stored in that persistent volume as part of Jenkins deployment, we'll just verify that everything has been restored, not just the front end, but also the back end for our Jenkins deployment. But that's it for the couple of demos. Let me switch back to slides. I think I see we have 15 minutes remaining. So we'll look at the slides, close it out, have a call to action, and then we'll see if we have any questions. So let me, okay, after demo. So if you see what you like, if you want to get started with PXBackup, we do have a free 30-day trial where you can use PXBackup on any Kubernetes cluster that you might have, EKS, OpenShift, VMware Tanzu, on-prem, in any cloud. You can give PXBackup a shot and use it to protect your containerized apps that are running on your Kubernetes cluster. If you want to like take the next step after that, if you want to start using it without even talking to a sales guy, just go to your AWS marketplace or IBM cloud marketplace and subscribe to those offerings that we have on there, so you can get started with PXBackup easily. And if you want to learn more about PXBackup, we definitely have our docs site, backup.docs.portworx.com. You can find this and many other demos and blogs on our YouTube and blog site. So youtube.com/portworx and portworx.com/blogs. You can find more content there. And obviously, like, you can reach out to me on Twitter or LinkedIn or any other social media platform. I do tweet about Portworx a lot, so you can find me easily. But with that, I think we'll close out this session. Again, thank you for staying with me, and I hope you learned and you are taking something away from this webinar. I don't see any questions for now. We can wait around for a couple of minutes. If you have any questions, feel free to put them on chat and we'll get to it live. If not, again, you can put those questions on as YouTube comments when we post this video on YouTube, or again, you can reach out to us through the different things that we just discussed. But yeah, if we don't get any questions in the next couple of minutes, we'll just end this webinar. And thank you once again for your time. I know we are getting close to the holiday season, so happy holidays, and we'll see you next year for another interesting monthly demo around AWS. Thank you.